Okay, so today we're going to dive into a really mind-bending question, isn't it?
It is, the classic one.
Yeah. If there's nothing outside the universe, what is it actually expanding into?
Right. It just stops you in your tracks.
Totally. It like rattles our everyday understanding of space, of how things grow.
Exactly. Our brains want to picture, a balloon inflating inside a room.
But the universe isn't like that.
Not really, no. It's not expanding into some pre-existing void. It's more like it's creating space itself as it goes.
Creating space.
Yeah, think about being an ant on that balloon surface. As it inflates, the surface area increases. Points get farther apart.
Ah, okay. So the ant isn't moving into anything off the balloon. The balloon's surface itself is just getting bigger.
Precisely. The universe is kind of like that surface. It's creating more surface, more space between things.
Okay, that helps wrap my head around it a bit. So how did we figure this out? What was the first big clue?
Well, that really starts with Edwin Hubble. Back in the day, he was observing distant galaxies.
And he saw them moving away.
Moving away, yeah. And, crucially, the farther away a galaxy was, the faster it seemed to be receding from us.
Which sounds like an explosion, maybe? Everything flying out from one spot.
That's the intuitive leap, but the data pointed somewhere else. It wasn't just galaxies flying through space. The better explanation, the one that fit, was that space itself was stretching, expanding.
Like raisins in bread dough rising. I think I've heard that analogy.
That's a great one. The raisins aren't walking through the dough expands and carries them apart.
And there's no single center raisin, right? Every raisin sees others moving away.
Exactly. No special center to the universe's expansion.
Mind-bending. Okay, is there a way we actually see this stretching, not just infer it from how galaxies move?
Oh, absolutely. We see it directly with something called redshift.
Redshift, okay.
So light travels as a wave. When light from a very distant galaxy travels across billions of years through space that is actively expanding,
The wave gets stretched out.
that's it. Longer wavelength means redder light. Think of stretching a rubber band with a wave drawn on it.
Right, the wave gets longer.
So light that might have started as blue can arrive here on Earth looking red. Or, for the really distant stuff,
Even redder.
way beyond red, into infrared. Like the light from the most distant galaxies we can see has been stretched maybe 40 times its original wavelength. It arrives as just faint heat.
Wow. So redshift is like a direct measurement of how much space has stretched since that light left.
Pretty much, yeah. It's powerful evidence.
And what about the oldest light of all, the sort of afterglow of the Big Bang?
Ah, the cosmic microwave background, the CMB.
Yes. That must be the ultimate example of this stretching, right?
It really is. We're seeing light from when the universe was incredibly young, just 380,000 years old.
A baby universe.
Tiny, yeah.
Yeah.
About a 1,000 times smaller than it is now, and much hotter. That ancient light has traveled so far through so much expanding space.
That it's stretched all the way to microwaves.
Exactly. It's just this faint background hiss now. About 1% of the static on an old analog TV. That was some CMB.
No way. Really?
Yep. And it's like this ultimate wall. We can't see light from earlier than that because the universe was opaque before then. It's our earliest snapshot.
Incredible. So, okay, we have this expansion, this stretching, proven by redshift and the CMB. But then things got even weirder, didn't they?
They did. Around 1998, a huge discovery. The expansion isn't slowing down like you might expect gravity to make it do.
It's speeding up.
It's accelerating, pushing itself apart faster and faster.
How is that possible? What's pushing it?
Well, that's the billion-dollar question, isn't it? We call the cause dark energy.
Dark energy makes up most of the universe, apparently.
Something like 68% of the total energy density, yeah. It's used as a property of space itself, sometimes called vacuum energy.
So as space expands,
You get more space,
Yeah.
and therefore you get more dark energy. And this energy has this weird, repulsive gravitational effect. It pushes things apart.
so more space means more push, which means faster expansion, which means more space. It's a feedback loop.
That seems to be the picture, yeah. Space making more of the stuff that makes it expand faster.
Okay, so if everything's accelerating away and light only travels so fast, what does that mean for what we can actually see out there? Is there a limit?
There absolutely is. We talk about the observable universe. It's basically a sphere around us.
How big?
The edge is about 46 billion light years away today. That's the distance light from the very early universe has traveled to reach us, considering the expansion that happened while it was traveling.
But there's more universe beyond that edge.
Oh, almost certainly. Vastly more. Maybe infinitely more. But light from those regions hasn't had enough time to get here yet. And because the expansion is accelerating, light from increasingly distant regions never will reach us.
So we're kind of trapped in our observable bubble, a cosmic prison made of light speed and expansion.
In a manner of speaking, yes. If the universe is infinite, we are literally observing 0% of the total.
0%. That's humbling. And this whole expansion idea, especially the really early fast bit, that leads to even bigger ideas, right? Like inflation,
Yeah.
multiverses.
That's right. The idea of inflation is that in the very first fraction of a second, the universe underwent this incredibly rapid exponential expansion.
Smoothed everything out.
Exactly. It smoothed out wrinkles and also stretched tiny quantum fluctuations into the seeds that eventually grew into galaxies and galaxy clusters.
Wow.
And a fascinating, though speculative, consequence of many inflation models is, well, maybe this inflation process doesn't stop everywhere at once.
Meaning,
Maybe new universes, new bubbles are constantly budding off. Our universe could be just one bubble in an infinite cosmic foam. A multiverse.
each bubble potentially with different laws of physics.
Potentially, yes. It's highly theoretical, of course, but it flows quite naturally from trying to understand that very initial violent expansion.
Okay, so let's bring it back. Our original question.
Sure.
What is the universe expanding into?
The answer seems to be nothing. It doesn't need an into.
It expands just by becoming more universe, creating its own space as it goes.
Right. It defines its own spatial relationships internally.
It reminds me of that analogy, asking what's north of the North Pole.
Exactly. The question imposes a framework, and outside, that doesn't apply. The North Pole is the definition of north in that context. There's no norther than that.
The universe is its own context.
Precisely.
So maybe a final thought to leave everyone with. It's kind of amazing, isn't it?
It's that.
That we are, in a way, the universe itself asking these questions. We are the expansion wondering where it's going.
Consciousness arising within this process, trying to understand itself.
Yeah. It just shows this endless capacity for wonder, for discovery within this magnificent, almost impossible process of the universe just becoming.